Hi, this is Jacob Nash with JNGL, and today we are looking at the Hypotenuse-Leg Theorem, HL Theorem. This is Unit 5B, Lesson 4. So here's what the theorem states. Might do this. Sorry, that doesn't work. Alright, if the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of the other right triangle, then the triangles are congruent. What would that look like? Well, let me get something on here. It's loading. Okay, I have to reload it. Sorry about that. Let me pause for a second. Okay, welcome back. Sorry about that. It sometimes freezes up when I try to do that. What would that look like? Well, they do have to have right angles in the triangles. And then the hypotenuse, which, if you don't know what that is, hypotenuse is the one that's across from the right angle opposite to it. So that's this. So those have to be congruent. And then also one of the legs. The legs are just the ones that aren't the hypotenuse. So it could be that, it could be that. So we'll just do this. That's what it would look like. And just by looking at that, you could tell that yes, they are congruent just because we see that. Alright, here's practice. Which are congruent. So let's try to figure out if by looking at these triangles, are they congruent? Alright, number one. We see right triangles, alright? Then we need congruent hypotenuses. Right there, yes, they are. And then also legs. So yes, these are congruent in number one. Now number two looks a little bit different. Try to think of this as if there's two triangles, not that they're necessarily together. That might make it a little easier. But we have the right angles, then we have congruent hypotenuses. They would be right here. And then we have legs also that are congruent. So also on number two, these would be congruent. On number three, we do have congruent right angles. We do have congruent legs, but we don't have congruent hypotenuses, as you can see right here. But the truth is, in fact, these triangles are congruent. They are, but just not by using the hypotenuse-leg theorem, but by using side angle side, it would be. Or sorry, just with the side angles, at least they're congruent. On the next page, we have number 4, which is two-column proof practice. Okay, so some of these things didn't come out, so sorry about that. Let's see. There we go. Okay, so it's given that MK is perpendicular to JL, K is the midpoint of JL, and JM equals ML. So this is why pretty much we learned the other units before this one, because you learned about what that was and what perpendicular congruent meant. And you need to prove that these two triangles are congruent. Well, let's do the statements. Remember, first we just restate the given. So it's given that MK, segment NK, is perpendicular to JL. We can actually draw that in the triangle. So, well, we can't draw that they're perpendicular, but the only way we can draw something on here that shows that it's perpendicular. And you know, when there's perpendicular, that means that it forms right angles. So there are right angles. So that's the first part that we can tell that we might be able to use this theorem to prove it. Alright, the next part is that K is the midpoint. Oh, sorry. K is the midpoint, which I'll just write M, of segment JL. What would that look like? Well, we know if there's a midpoint, it makes the two segments that are out of it, that it's in the middle of, are congruent. So that's the second part that we need to prove that this is congruent. So we can already tell that, but in fact, that's something that we should write in this table. Now that we know that JK is congruent to KL. That isn't given. That just means definition of midpoint. So what's the definition of a midpoint? Well, that proves what we just said in the statement. Alright, but we still have one more thing that's given that we need to put in the table. JM equals ML. So this time it doesn't look like we have any reflexive things, but JM equals ML. Alright, that's these two, so we can just draw that on here, that these hypotenuses, which these actually are, because they're opposite to the right angles, they're congruent. That's just given. We didn't do anything to prove that. Okay, then the last thing we can do is now, let's see if we can actually prove this now. Well, the first thing that we have is that there's right angles. That's the first part. Yes, that is on there. The next part is, are there congruent hypotenuses? Yes, they're right here. Are there congruent legs? Yes, there are. So now we can say that triangle JKM is congruent to triangle MKL. And that is because of the Hypotenuse-Leg theorem. That is how you would do that. Thank you for watching, and be sure to see some of the other videos, especially lesson 1 if you have no clue how to do the 2-column proofs. Thank you for watching.